All right, in this video, we're going to cover two other learning objectives. So this one is the second derivative test. All right, so the second derivative test is if you have a critical point. All right, critical point can be a min or a max. All right, and it says if our second derivative is positive, then we're concave up. So the second derivative is positive, that has to be a minimum. If my second derivative is negative, we're concave down, and that has to be a maximum. All right, so just knowing that, all right, knowing the concavity tells you if you have a local min or a local max. Now let f be a function such that f of -1 equals 1. All right, they give us the derivative function, and then which of the following statements is true. All right, so we're looking at relative max and mins. All right, we want to use the second derivative test. They give us the first derivative. So if we want to take the second derivative, we do the derivative of the derivative. All right, so the derivative of negative x squared is going to be negative 2x. Derivative of xy, we have to do the product rule. X dy dx plus y, the derivative of x is 1, plus 2y. Oh, 2y dy dx, because I took the derivative of y. All right, so that is my second derivative. I'm doing this whole thing at -1, 1. So I'm going to plug -1 in, or -1 in for x and 1 in for y. So x is -1, x is negative. What is dy dx going to be? All right, well, that we can use our original equation that's given to us here. All right, so dy dx is going to be -1 squared minus -1 times 1 plus 1 squared minus 1. All right, so what's that going to be? -1 plus 1 plus 1 minus 1 is 0. That doesn't seem right. All right, so the derivative is 0, so when I plug that in, it's going to be 0 plus y is 1 plus 2 times 1 times 1. All right, so this part's going to go away. This is going to give us positive 2 minus 1, this is 0, which equals 1. All right, so when I plug all this stuff in, I end up getting a positive value for my second derivative. So my derivative is positive. That means it's concave up. It means that I have to get a minimum for my graph. All right, so I have a relative minimum for my function. All right, so f is a twice differentiable function. Which of the following conclude that we have an absolute max of f on -5 to 5? All right, so part 1 is f prime of 2 equals 0. So if our first derivative is 0, that means we have a horizontal tangent. But that's not enough to know if it's a maximum or a minimum, because it could look like either of these graphs that I just drew. So 1 on itself is not enough to determine it's an absolute max. 2, x equals 2 is the only critical point, and the second derivative is negative. So if the second derivative is negative, it's concave down. And x being the only critical point means that's the only maximum on this place. So 2 is actually enough to know this is going to be an absolute max. So it's a local max, but because there's no other maximums, it has to be the absolute max. And then x equals 2 is the only critical point, and f of 2 is bigger than both f of 5 and -5. All right, so if it's a critical point, it could be a max, or it could be a min. But if it's the bigger value of all the other ones, f of 2 would have to be up here, and f of 5 and -5 would have to be down there. So that's actually also enough to determine this is an absolute max, because the absolute maxes can only happen at the endpoints and the critical points. And the fact that this is the biggest value means that also works. So our final answer, 2 and 3 work. All right, 27, we have this differential function. We know values of f prime and f double prime. Which of these do we know are true? And again, they're all about max and mins. Max and mins happen when my first derivative is 0. And if my first derivative is 0, then I look at the second derivative. The second derivative being negative means it's concave down, and that's a maximum. The second derivative being positive means it's concave up, and that's a minimum. So we get a maximum at 1, that means 2 is correct, and a minimum at 4, so 4, that's not right. And we know there is a relative max at 1, so 1 is out. So 2 is the only correct answer. All right, so f prime of x is x squared plus 2x minus 24. Determine all the critical points and then use the second derivative test. So the first thing is to find our critical points. We set our derivative function equal to 0. In this case, we have a quadratic, so I'm going to factor. See, 24 is 6 times 4. Yeah, so I can do x plus 6 and x minus 4. We get a critical point at negative 6, a critical point at 4. Right. So now what I want to do is figure out the concavity at those points. So to figure out concavity, I have to take the second derivative, which is the derivative of the derivative. So that's going to be 2x plus 2. Right. I want to plug in negative 6 to figure out the concavity there. It's going to be negative 12 plus 2 is 10. No, sorry, negative 10. All right, so my derivative, or my second derivative is negative, which means that it is concave down, which means this is going to be a maximum. Like, so whenever if I have a max or a min, concave down tells me it's a maximum. Same thing for 4. And that gives me positive 10. Positive 10 means I'm concave up like a cup. It means I'm going to get a minimum down there. So 4 is a minimum. Again, so all these pages kind of use the same techniques the whole way through. All right, this one's just using the second derivative test. All right, concave up means you have a minimum. Concave down means you have a maximum. All right, 5.8 is about sketching graphs. You don't actually like sketch a whole graph for a question on the AP exam, but they kind of get you to do a part of it. All right, for 29, they give us this table, and they want to say, what are the points of inflection? All right, so this is really just a definition thing. A point of inflection is when your second derivative switches from positive to negative or negative to positive. It switches sign. All right, so a point of inflection would be like these two places, because it's switching from being a cup to a frown or a frown to a cup. All right, so it's changing the curvature of the graph, and that happens once and twice. The third time it stays positive, so it's not a point of inflection. So at 3 and 9, we have a point of inflection. All right, 30, we have this function. On which intervals is it both decreasing and concave down? All right, so decreasing, we have to use the first derivative. Concave down, we have to use the second derivative. So the first derivative, now we need to set it equal to 0. We get positive 8 and negative 2. So we have to make our number line negative 2, oops, positive 8. Do our test points. If I plug in 0, I'm going to get negative. If I plug in 10, I'm going to get positive. Negative 5, I'm going to get 2 negatives, which make a positive. All right, so now I know where my graph is increasing and decreasing. That's all the first derivative. The second derivative is concavity. So I take the derivative of the derivative. Put 3 there. Write my test points. If I plug in 0, I'm going to get a negative. And if I plug in 5, I'm going to get a positive. All right. And now I want to compare them. All right, I want to be both decreasing and concave down. So for my derivative, I need to be between negative 2 and 8 to be decreasing. And my second derivative to be concave down, I got to be between negative infinity and 3. And where's the overlap between those? It starts at negative 2 and it ends at 3. All right, so B is my correct answer. All right, 31, let f be a function that f prime is bigger than 0 and f double prime is less than 0 on the interval 0 to 2. So we have 0, oops, we have 1, and we have 2. And my graph is increasing but concave down. So increasing and concave down is going to be the kind of left-hand side of the frown. So is f of 2 bigger than f of 0? Yes, it has to be because it's increasing. So this one is right. Is f of 2 bigger than f of 1, same reason, it's increasing, so it has to be true. All right, f of 2 minus f of 1 is the difference between this point and that point. F of 1 minus f of 0 is the distance between that point and that point. All right, because I'm just subtracting these is the distance between them. All right, so is that first distance bigger than the second distance? No. All right, so the final answer is 1 and 2 are right. All right, because it's increasing, but because it's concave down, 3 is not right. And then the short answer, I draw a graph, possible graph for each of these things. All right, if I'm concave up, concave down, this means I'm increasing, and this means I'm decreasing. So first derivative, increasing and decreasing. Second derivative, concave up and concave down. So if I'm concave up and increasing, that is the right side of the cup. If I'm concave up but decreasing, that is the left side of the cup. If I'm concave down and increasing, that is the concave down and increasing is the left side of the frown. Concave down and decreasing is the right side of the frown. So again, if you just think about the 4 parts, all right, the cup you break into 2, and the frown you break into 2, just figure out which one goes where. All right, this is, both of these have to do with concave up, concave down. This one's decreasing, increasing, increasing, decreasing. All right, so just put them in the right place, knowing that it's kind of the 4 parts of the frown and the cup.